A few feet below the ground lies an expansive network of interconnected fungi, plants and bacteria. This is known as the mycelial network, but has gained the popular term the Wood Wide Web.
Plant and fungal membranes touch, forming thousands of connections throughout the soil beneath our feet.
On first contact, the fungal hyphae are chemically attracted to the roots and form associations in coil or net shapes. The associated plant takes in carbon through photosynthesis, which travels all the way down and feeds into the roots. The roots act as a carbohydrate sink from the constant breaking down and exchanging across membranes.
The periarbuscular membrane is an active, bustling area with a constant back and forth sharing of nutrients and carbohydrates. The plant donates carbohydrates and some fats through several types of specific transporters. Fungi are able to break down dead organic material on the forest floor using enzymes, absorbing the nitrogen and phosphates, completing the nutrient cycle.
Bacteria also play a huge role in these associations. Many soil-living bacteria feed off of or live inside hyphae, as well as fixing nitrogen within plant roots. Often, multiple fungi and bacteria will compete with each other for a partnership with the tree. Whichever association provides the better deal gets to stay, while the other gets cut off.
This ancient partnership is around 500 million years old, with fossil evidence proving this interaction predates roots. Since then, these relationships have become more complex, exchanging nutrients instead of just water and co-evolutionarily supporting each other.
Most of these partnerships benefit both the plant and the fungus, such as seen in the fly agaric and birch trees. However, some plants, known as epiparasites, don't produce energy from the sun, but take what they need to grow from the fungi without benefiting the fungi in return.
It's a very vague concept, it's not really very well defined. We know that fungi can grow in association with plant roots, and that's been known for a long time, but the scales of this aren't particularly known. Plant disease and symbiosis has evolved numerous times, so nothing is stable in evolutionary time. It's always going to be changing. They've all got the same genes, it's how they choose to use the genes that differs.
Suzanne Simard coined the term mother tree, referring to the idea that there's a singular tree which is a central node for a system of connected trees. It also refers to the idea that older trees in the network act maternally towards the younger saplings in the network. This theory has been called into question as a result of the modern view of it being a decentralized and adapting network, as well as there being no concrete evidence of individuals in the network being prioritized over others. Other more popular theories include the idea of the Wood Wide Web, where the root system supposedly resembles the internet, or the idea that the network resembles the neuron system in our brain. These theories fail to encapsulate all the complex interactions between the various organisms in the system, and whilst they're useful as basic tools to explain a general concept of the system, people tend to think of them as quite literal definitions, which they unfortunately are not. Pop culture reference is not limited to just James Cameron's Avatar, but it's also featured in Star Trek's Spore Drive and Annihilation's Shimmer. All three of these films heavily feature mycelial growth as part of their sci-fi narrative. These films are likely a reflection on recent science on fungal circuitry and communication, such as Adamansky's studies on fungal circuitry. The aforementioned Simard and authors such as Paul Stamets, Doug Behrend, and Merlin Sheldrake have all catapulted the study of mycology in popular media.
There's many different threats. So in agricultural environments, it's the chemicals, inputs that we're putting into the soil and the way that we're managing the land. In some recreational areas, it's just foot traffic. It causes soil compaction, and that will have a big effect. And then wider, it's the unknowns of climate change.
The monoculture style of modern farming is particularly harmful to mycorrhizal networks, and most farming practices destroy them year on year, preventing proper establishment and rendering them ineffective.
A decrease in mycorrhizal productivity can lead to a decrease in plant fitness. This has a knock-on effect as plants are less able to trap atmospheric carbon. In its drive to combat climate change and maintain food security for an exponentially increasing population, these natural relationships and systems may hold the key for the future of our species.